All right, we're going to be looking at Geometry Lesson 64. This picks up on page 424. So I'm going to try to draw some pictures for some of this stuff where it's kind of hard to do on the board with the graphics and stuff that I have available from this. But we're talking about angles interior to circles, interior angles. And then they use some terminology in here that we're not necessarily used to. So it's new terminology we want to make note of. Okay? What we see here is the word subtend. Subtend. Okay? Austin, can you tell me what subtend means? Okay, so I've got arc EDF, or sorry, angle EDF. Do we see that? Okay. The segment that subtends it is the one that shares the endpoints of that angle. So EF is the line segment, and arc EF is the arc that subtends it. Okay, so it's at the end of it. Okay, it connects the two ends of that angle. Does that make sense? I want to see that it makes sense because when I'm going to use that terminology, subtends, I'm going to ask you, hey, what subtends this angle? What line segment subtends this angle? What arc subtends this angle? And subtend is not a word that you're used to up to this point. So I want to make sure that you understand it. So angle EDF is subtended by arc EF or segment EF. Okay, we're familiar with that. Brings us up to speed. Yep, I think so. Hope so. Yep. All right, Theorem 64-1. Brady, why don't you tell me about Theorem 64-1? Okay. The measure of an angle formed by a tangent. So if you'll notice that line AD is a tangent line, and I have chord CB here. So it says the angle formed by that. So that would be this angle right here is equal to half of the arc that subtends it. The arc that subtends it, for lack of a use of other colors, is going to be this arc right here. Okay, so if I know what arc CEB is, I know that my green angle right here is going to be half of that. Okay, so if I knew that arc CEB was 140 degrees, right, what would angle CBA be? It would be 70. Now, the opposite is also true, right? Because if I know what this angle is, that green angle, can I figure out what the arc is going to be? Yeah, I'm going to take that angle and do what with it? Multiply it by 2. So if I know that angle CBA is 80 degrees, what do I know arc CEB is going to be? 160, right? Take 80 times 2. And it's not just that side of it. We could look at this side over here. Okay? What is the arc that subtends angle CBD? Anybody tell me? What is the arc that subtends angle CBD? Arc what? Arc CB, okay? This is the arc that subtends that angle. Okay? It has its endpoints at the same ends, okay? So if I knew that arc CB was 90 degrees, okay, what would angle CBD be? No. It would be half of the arc. So if the arc is 90, the angle is 45. Okay? All right, so if angle ABC is going to be 1/2 arc BEC. If I've got angle CBD, okay, it is 1/2 arc BC. So I wasn't asking you any information that you actually couldn't have looked up and read. Okay. All right. Then we have theorem 64-2. There's not a lot of theorems here. There's really only two. We got theorem 64-2. Mariah, could you read theorem 64-2 for me?
Measure of an angle formed by two chords intersecting in a circle is equal to half the sum of intersecting parts.
Okay, so what I have here is I've got angle 1 and I've got angle 2. Okay, angle 1 is 1/2 the sum of arc AD and arc BC. So this blue angle is half of the sum of these two arcs. Okay, so if I knew that arc AD, let's say that that is 80 degrees. Okay, and I know that arc BC is, let's call it 100 degrees. Okay, what do I know that angle 1 is then? 60? 90. I'm taking 100 plus 80. What's 100 plus 80? 180. What's 180 divided by 2? What's 1/2 of 180? 90. So this would be 90 degrees. Okay, angle 2 is going to be 1/2 arc AB plus arc DC. If I know what arc AB is and I know what arc DC is, I'm going to add them together and divide by 2 to find out what that angle is. Okay? What we're doing is we're averaging those outside arcs. Because if you'll notice, this is not in the center of the circle. If it had been in the center of the circle, then these would be central angles and they would be half of their intercepted arcs. What we're talking about here is their average. Okay, actually the central angle would be the same as the intercepted arc. So instead of it being the same, I have to average the two outsides, okay, and that's what's going to be that new angle. Okay, Darren, you're giving me kind of a confused look. We need to see some in action here. Okay, let's move over to some of our questions, because I think that's the end of that. Okay, lesson 64, let's come up to question number 1. Okay, this is actually going to use that 64-2. We want to find angle X. Okay, Aaron, can you tell me how I'm going to find angle X? 58 and 52. Okay, 58 plus 52. What am I going to do with those after I've added them? Divide by 2. Okay, so 58 plus 52, if I've got this right, should be what, 110? What's 110 divided by 2? 55 degrees. Okay, 55 degrees. It's not too hard, right? We can do that. Okay. It's just an average of those two subtending arcs. Okay, let's scroll down here to number 2. Okay, this is going to use 64-1. What is measure angle WXY? Okay, what is that angle right there? Given that XY is tangent. So what we're saying is we know WX is a chord. We know XY is a tangent. So if I want to find angle WXY, Darian, what do I need to do to find that? What's that? Okay, at that point you need to raise your hand and say, I don't get this, right? Can you go back and explain that again? Okay, so let's go back. Okay, that's this part right here. Okay? This green angle, right? Okay, so what I've got here is I've got a chord and a tangent line. Okay? The angle formed by that chord and that tangent line is 1/2 of that arc that subtends it. You follow me now? So if I knew that this was 216, I would divide it by 2 to get that angle. Okay, so let's go back to our question. Let's see if we can't figure it out. Okay, so how do I find that? 216 divided by 2. Okay, what's that going to give me? 108. Okay, now, if I was looking for, let's say I was looking for this angle right here. Well, there's only 360 degrees in a circle, so there's a couple things I could do. Either one, I could look at that and say, if that's 108, then that's got to be 180 minus 108 because it's a straight line. Or I could take 360 minus 216, find out what this angle is going to be, divide it by 2, and get that guy right there, right? So a couple of things that we could do if we needed to find a different angle there. All right, let's come back up to number 3. Matt, line CD is tangent to circle A. Find the measure of angle CAD. How are you going to do that? Right, because arc CA subtends angle CAD, so 130 divided by 2, what is that answer? 65. Okay, 65, very good. Are we picking this up a little bit more now? Okay, there's really only 2 theorems to work with. Okay, let's come down to number 4. Okay, find, measure angle BPD. BPD, that's this one right here. That's BPD. Okay, Matt, let's see, I've already done Matt. Miss IL, how are we going to find measure angle BPD? Okay, what's 164 plus 142? Is that 306? 306. 306 divided by 2, 153. 153 degrees, works right there. Okay? So far, so good. Let's come down here. Let's roll that guy over. 5, let's see, Austin in the diagram below. We want to find measure angle WXY given XY is tangent, which means WX is a chord, and I've got a tangent line. So what am I going to do to find that angle? What is 139 divided by 2? $69.5 degrees. Okay, getting better and better all the time. Darian, are you picking it up more now? More we see it. Okay. All right, number 6. Find X in the diagram below. Minor, have I picked on you much? Minor, how am I going to find X? 76 plus, you said 38? Huh? Divided by 2. 76 plus 38, we know we're going to get probably, what, 114?
Yeah.
114 divided by 2. 57, I hear several people say 57 degrees. Minor, do you concur? No. Okay, what did you get? 95 degrees. Okay, take that calculator. Tell me what 76 plus 38 is. What's 114 divided by 2? Got 57 that time. Okay. All right. All right, number 7. I'm trying to look at who I haven't picked up on. Mick. Mick, we want to find angle ABC. Okay, right there, given that BC is tangent. 217 divided by 2, he says. Can you tell me what 217 divided by 2 is? 108.5. What's my label on this? Degrees. Okay, 185 or 108.5 degrees. I like to, on a day where it feels like 10 below outside, I like to see things like 108.5 degrees. I know it's not literal degrees in our sense, but it's nice to think about. Okay. Number 8, Brady. Angle A in the diagram below. How do we find that? 65 plus 175. Okay, what's 65 plus 175? 240. Divided by 2. What's 240 divided by 2? 120 degrees. Okay, that is correct. All right, let's see. This is our last question. So I'm going to stop it here. And I want you guys to answer this question. And I'm going to walk around and check it. When you got it right, I'll let you start in on your homework.